We are at Daimler's test site and, as you can already see, today it's not about a car, but about a truck. However, it doesn't run on diesel, but on hydrogen. I'm curious to hear what there is to tell, and I'll let Christoph Funz explain it to me, because he is a developer at Daimler. From a purely visual point of view, the alternative drive would not be noticeable at all, if it weren't for this special bumper sticker. Hello Christoph.
Hello Emmanuel, nice to have you here.
I heard we can go for a spin together with the part now?
Yes, shall we start right away? Let's get started then.
The Giant starts moving almost silently, without any jerking, unlike what you see with conventional diesel trucks.
We're sitting here in a truck for heavy long-distance transport, which means we're driving right now with 40 tons and we have a fuel cell drive. That means we have a hydrogen tank on board and the fuel cell generates electricity with hydrogen from the tank and oxygen from the ambient air.
With
this electric current we either drive directly via the electric motor, or we charge a small high-voltage battery that is there to buffer power peaks or to recuperate, let's say, braking energy. When braking, the electric motor then works as a generator and produces electricity.
The truck manufacturer has already started intensive testing of the advanced prototype of its 2020 Mercedes-Benz Gen2 truck at the end of April.
We have two fuel cell systems here with 150 kilowatts each, so that's a total of 300 kilowatts where the fuel cell can deliver in maximum power mode, so to speak. The fuel cell must be specially cooled. Fuel cell systems normally run at about 60 degrees Celsius with the technology we use, which means that all the waste heat that accumulates there falls at a relatively low temperature level and you still have to cool everything. This means that the cooling system is very important in a fuel cell vehicle and must also be well conceptualized and designed.
The wide-ranging series of tests, which are extremely demanding for the vehicle and its components, focus on continuous use, different weather and road conditions and various driving maneuvers.
The most noticeable difference is, of course, now when you drive, the vehicle is super quiet. It's vibration-free, so it's a very pleasant driving experience. I have to be honest and say that the driver doesn't notice any of the other technology. It's all fully automatic, which means it's a very pleasant, quiet ride, which is very important in long-distance transport, when people simply spend many hours a day in the vehicle. We have a 2-speed gearbox in the vehicle and we only really need first gear for steep hills or when starting off with a full load. That means that as soon as the vehicle is rolling, we are in second gear, and then it's a bit like with the suburban railway. In principle, we drive here in a fixed gear without any interruption of tractive power, and that is of course very pleasant when driving up long hills, for example. You don't have to change gears. You don't have to catch the right moment. You always drive automatically in your fixed gear.
The development engineers at Daimler Trucks designed the Gen2 truck to meet the same durability requirements for vehicle and components as a comparable conventional Mercedes-Benz Actros. This means 1.2 million kilometers of mileage, 10 years of operation and a total of 25,000 operating hours. Christoph, you just mentioned thermal management is also relatively important. What do we see back here now?
Here we see our technology tower. We have installed additional coolers and fans because we have the situation with the fuel cell that the amount of energy that is generated is at a relatively low temperature level. That means we need a relatively large cooling surface. We can't cope with the normal vehicle radiator at the front. That's why we have installed additional coolers, which we need at outside temperatures of around 35 degrees or more.
Daimler Truck's development plan calls for tests on public roads in 2021. Customer trials are scheduled to begin in 2023 and the first production vehicles of the Gen2 truck are to be handed over to customers from 2027.
The requirements for this truck were, so once future studies were made and it came out that this truck should be able to do exactly the same, at least, as the current trucks. So in terms of range, speed, gradient profiles, and then we took these requirements and developed the concept. Hydrogen has many advantages over battery electric vehicles. One of them is clearly the range. We can go much further with it. We don't have the problem with the weight, and the refueling times are also better. You refuel much faster than the truck would have to be recharged with a battery.
The subject of hydrogen is not new territory for Mercedes-Benz and Daimler. As early as 2003, they launched the F-Cell, a small hydrogen series based on the then A-Class. A fuel cell B-Class followed later.
We used knowledge, know-how that was available at Daimler and the group, through over 20 years of research and development from the fuel cell sector and in hydrogen as well. We then looked at where the requirements are and we came to the dimensioning via optimization loops and finally to the vehicle that you see behind me now.
There is only one question left. What can the hydrogen truck actually do?
Well, the truck is electric, which means that the electric motor that we have installed here has 460 kilowatts of continuous power, which is about 610 horsepower. So it's already nominally very powerful. But you can always overload an electric motor for short periods of time, so to speak. This means that for short moments, less than a minute, you can deliver an additional 200 kilowatts. As far as consumption is concerned, we are using a hydrogen tank with liquid hydrogen in the vehicle, with about 80 kilograms of hydrogen on board, and we want to achieve a range of 1,000 kilometers with such a vehicle in heavy long-distance traffic.
Time for a conclusion. Yes, the day was really very interesting. I learned a lot and I think this technology really has a future, and I'm looking forward to seeing when it actually goes into production on our roads.